today's class we are going to talk about multiplexing. Okay, multiplexing in general it will have various input line and then we'll have one output line. Okay, it is going to have various n number of input lines and then we'll have only one output line. For example, if you take a multiplexing, okay, which has got 8 input lines. So how many input lines is there? 8 input lines. We are going to select only one channel will go to the output. That means out of 8 we are going to select 3, which means we should have 3 selection lines. In this sense, A, B and C, let it be the 3 selection lines. For example, if I am going to choose selection lines value as 0, A is equal to 0, B is equal to 0, C is equal to 0, which means channel 1 input will get selected and that will come as an output. Got it? And for example, if I am going to choose the selection line input as 0, 0, 1, what will happen? Second channel input will get selected and then same thing will come as an output. Similarly, if I want the last channel, I should give the selection lines input as 1, 1, 1, so that the last 8 channel input will be selected and then same thing will come as an output. So in general, for multiplexing, we will have n number of input. At a time, we are going to select any one channel. How to select that? We are going to select it by using the selection lines. So if we have 8 input lines, we need how many selection lines? We need 3 selection. So in general, you can look, if there are n variables available, then we have n minus 1 selection lines. So 2 to the power of n is n minus 1 is to 1 much. For example, let us assume we have variable 4, n is equal to 4. So how many selection lines will have? 4 minus 1, 3 selection lines. So what will be the max? 2 to the power of n minus 1. That is 2 to the power of 4 minus 1 is 2 to the power of 3. What is 2 to the power of 3? It is 8 is to 1 max. Got it? So in general, we have, for example, the same example which I quoted, if there are 4 variables, we need 3 selection lines. Okay, so this 2 to the power of 3 is to 1, that is 8 into 1. Similarly, if you are going to consider the variable as 3, then you will have how many selection? As per the formula, n minus 1, that is 2. That means you will have 2 to the power of 2 is to 1, that is 4 is to 1. Got it? So in general, they are given a question. This is basically how many variables? A, B, C and D. So it is how many variables? 4 variables. That means you are going to design for 4 variables you are going to design 8 is to 1. So this is the question which is basically given. Okay, they are given the value as 0, 1, 2, 3, 4, 9, 13, 14, 15. For this value, we are going to design that 8 is to 1 max. Okay, let us see how to do it. As you could able to see in this particular diagram. Okay, so this is how many input lines are there? From I0, I1, I2, I3, I4, I5, I6, I7. We have got 8 input lines. As I said before, we have how many selection lines are there? B, C and D. We have 3 selections. So based upon this values of B, C, D, any one channel will be selected and that will be given as an output. So this is the basic diagram of 8 is to 1. Now based upon the value which is given in the question, okay, you could able to see what are the value. First one is 0. So if you represent 0, I can represent as 0, 0, 0, 0. And second one, 1. So 0, 0, 0, 1. Basically first what should I do is, I should list out all the possible combinations. When I list out all the possible combination, goes from 0, 0, 0 to maximum can go up to 1, 1, 1. And this is the decimal equivalent value I have just listed out. And the output F is basically represented by F, which can take a value of 1 or 0. If whatever the value they are given, based upon that, okay, if 0 is given, so what should I put here? I should put 1. Then 1 is given, so I should put 1. 2 is given, so I am putting across 2, I am putting 1. And then 3 is given, so across 3 I am putting 1. Similarly 4 is given, across 4 I am given 1. Is there any 5 value? 5, 6, 7, 8 are not there, so I am putting here. So I believe that everyone understood how to design this particular table based upon the question. So I think till that you could able to follow. Now you can able to see a table which is written here. These are nothing but all the input I0, I1, I2, I3, I4, I5, I6 and I7. So totally we have got 8 inputs varying from I0 to I7. Okay, and then we have A bar as well as A, right? So this corresponds to value 0, 1, 2, 3, 4, 5, 6, 7 and then 8, 9, 10, 11, 12, 13, 14, 15 corresponding to same values from 0 to the maximum of 15 values. Okay, so first you have to write this and then second step is we have to encircle the number which is having the value 1. Which is having value 1? 0 is having value 1, 1 is having a value 1, 2 is having a value 1, 3 is having value 1, 4. And 5, 6, 7 they are having a value 0. So whichever value is having 1 you have to encircle. Can you able to see? 0 is having a value 1, 1, 2, 3, 4 is having a value 1, 5, 6, 7, 8 is having a value 0. So don't encircle it. And 9 is having a value 1, so encircle it. Okay. So like this you have to complete this till 0 to. Now we have to look into I0 values. One is 0, other one is 8. And then which one we have encircled? We have encircled only 0. That corresponds to which variable? A dash. So I have to put A dash. Right? And second one, both the values I encircled. A dash is also encircled, A is also encircled. In that case, you have to put 1. Here you can see again, which is encircled? A dash is encircled, so I should put A dash. Here you could able to see again A dash is already encircled, you have to put A dash. Here A value is encircled, so you have to put A. Here A is encircled, you have to put A. Here only A is encircled, you have to put A. So in this case, you have seen two possibilities. One, only one is encircled, you have to put the corresponding term, and both are encircled. When both are encircled, you have to put 1. Suppose both are not encircled, then what you will do? You have to mark 0, as simple as that. Both are not encircled, you have to mark it as 0. Got it?
Yes, sir.
Okay, let us see one more example. Probably in this manual they have given this particular question. They have given the values as 2, 3, 4, 5, 13, 15 and then they have also listed out the values of don't graph. So since they have given don't graph, probably we can also consider the value to be 1 for our continuity. Okay, so same thing we have done. Okay, so in this particular example, previous example we have taken A, okay, as the input. In this case we have taken the values of D0 as input. So instead of previous example we have seen I0 to I7, here we are putting from D0 to D7, but the procedure remains the same. Again, based upon the values which is given in the question, 0, 1, 2, 3, 4, 5 until 15 we have written. And which one you have to encircle? What are the values which is given in the question? We have to encircle. Yes? So you could able to see here both the values are not encircled. Previous example we could not able to see this case. Here both the values are not encircled, so the output will be 0. Both are encircled, so it is 1. Both are encircled 1. Both are not encircled 0. Both are encircled 1. Both are encircled 1. Here only this is encircled. What does that corresponds to? D. Here again only 15 is encircled. What does that corresponds to? D. So here mentioned. Okay, so this is another example. Okay, as per the manual this question is given, so we have taken this example also. Now let us see the so this is the table which you have got. Yeah, as per the previous discussion we have seen D0 value corresponds to 0 and then D1 value is equal to 1, yeah, and then D2 value equal to 1. So how we are getting this column? Just by looking at the previous. Can you able to see what is the value of D0? What is the value of D1? What is the value of D2? What is the value of D3? The same thing we have just mentioned in the manual. This is the manual which is given to you. Okay, can you able to see how we got this value? Yes. So in the exam they will give that, just they will give the question. So to get this you have to do a small calculation as I have demonstrated. Once you have done that, we will be getting this value. Right? And this is the IC which is given to you. The IC number is 74LX151. So this is the 8:1 multiplexing IC which is given to you. As you could be able to see, at any point of time we have 3 selection lines A, B and C. based upon the selection length, we can select one input that will be coming out. And the circuit connection is explained, shown over here. You have to follow the same circuit connection, and then for various combinations of the input, we have to ensure that this is the corresponding output you will be getting. So what is the, for example, let me tell what is the first input? A, B, C and D or value are equal to 0. So here you could able to see input A, B and C. All these things you have to feed with 0 value, and then D also should be 0. So for this combination, what is the output you should get? The output should be equivalent to 0. Similarly, you have to check this entire table. Okay, so the second part is we will just connect the connection as per the circuit connection shown here, and then we will ensure that we are getting this function. Can you able to follow till this? Yes. So now we are going to connect this using the hardware kit available. So we have to verify this particular table for various inputs. We are going to verify what is the output we are going to get. Okay. So this is the connection. You will be able to see pin number 4 should be connected to ground. Pin number 2 and 3 should be connected together and should be connected to VCC. Pin number 1 should be connected to ground. Pin number 4 and 5 should be connected together and then should be connected to VCC. And pin number 12, 13 should be connected together and then should be connected to D. And you could able to see the inputs 9, 10 and 11. You have to connect the input A, B and C respectively. Pin number 7 again you have to connect it to the ground. Pin number 8 it is again connected to the ground. We will be taking the output from the pin number 5 and we will be giving the power supply to the IC to the pin number 16 which is plus 5 volt. The IC which you are going to use is 74LS151. Okay, we are just connected. Let us verify this particular table over here. So this is the IC which you have used, that is 74LS151, which is 8:1 mux. And I have given, these are the 4 inputs A, B, C and D, and this one which is connected to the pin number 3 is nothing but the output. Now let us verify the table. I am just turning on this particular kit. For all the 4 values A, B, C and D equal to 0, the output is equal to 0. It is evident from here. Now let me give the values like 0, 0, 1, 0 where the output should be 1. So 0, 0, 1, 0. Okay, this turned off. Yeah, 0, 0, 1, 0, you could able to see you are getting the output 1. If I give 0, 0, 0, 0, the output should be equal to 0. So it is evident that for 0, 0, 0, 0, the output is equal to 0. And similarly, for the cases 1, 1, 1, 1, the output is equivalent to 1. You can also verify from the previous slide which I have described. And similarly for 0, 1, 0, 1, 0, you could able to see the output is 1, which can also be verified from the table which you have seen. Similarly, you have to verify for all the 16 combination whether you are getting the output. So with this, we have come to the conclusion of 8:1 max. We have seen how to design the multiplexer and then we have verified using the logic gates. Thank you, dear students.